rational equation, and it's a rational equation because you've got a variable in the denominator. You've really got a polynomial over a polynomial without getting into why that is a polynomial out over a polynomial. So what we want to do is we want to completely factor our denominators. Does not apply in this case. We want to find the LCD, the least common denominator. So we want to look at all of our denominators to do so. 4 is over 1. We don't care about the 1. 9 is over 1. 9 over 1 is 9. 4 over 1 is 4. We don't want to look at the ones. We want to look at this denominator though. Let's keep the negative sign with the numerator. It'll make it easier. So we want to note this denominator. So our LCD, in the case of where you just have a single visible denominator, is that single visible denominator, which is 8z in this case. We then want to take that LCD and multiply it by both sides. What we do to one side of an equation, it's got its equal sign here. We want to do to the other side of the equation. We can't just do that to a term. We have to we have to do what we do to one side of an equation, we need to do to the other side. So let's write down our LCD first. 8z times what's on this entire side, which is just a 4, equals 8c times what's on this entire side, which is 9 minus 3 over 8z. So let's see how that 8z really helped us. 8 times 4 is 32 times z. Multiplication over adding a negative, so you can think of it as multiplication over addition. So we want to distribute. So 8z times 9 plus a negative, if you will. You can sneak in a plus sign if you want to. 8z times 3 over 8z. Now this 8z and this 8z cancel. So you can see how this LCD helped us eliminate the fractions. So what do we have here? 8 times 9 is 72. Z minus 3. Now we have a linear equation. Because it's linear because the understood exponents are 1. So it's a linear equation, which are pretty easy to solve. So we want to move how you go about this. Some of you may do it a different way. You might be moving to this side or that side. That's okay. So the opposite of adding 72 is subtracting 72. So that means 72 minus 72 is really 0 times z is 0. 0 times z is 0. So that's why we do that. And 0 minus 3 is still negative 3. So 32 minus 72 is negative 40z. Now we want to get z by itself. The opposite of multiplying by negative 40 is dividing. So we want to divide both sides by negative 40. These guys go away as well as the signs do. Negative over negative is positive. Negative over negative is positive, so we get a positive here. 3 over 40. Can't be reduced. If I put it in my calculator in Math Fracket, it won't reduce any further. So I know I'm done. Anybody have any questions on this first solving rational equation problem? Anybody have any questions? Just going to get another sip of tea. I've got these, I get allergy shots, and so I've got bad summer allergies. Let me just put it that way. So I gotta make sure I keep my throat hydrated. Let's go on. So let's take a look at this problem. We want to solve for z. 4 plus 6 divided by z equals 5 halves. We want to solve that. So the first step is factoring your denominators, but we can't factor any of these denominators here. So we're going to go to the next step, which is to find the least common denominator. So this doesn't have a visible denominator. This does. So I'm going to write down the z. Move it along. I'm looking at the next denominator. It's a 2. So I'm going to write it down. If it were a z, we wouldn't write it down again, because remember, the z we would be using to multiply. We would multiply 4 by z, this term by z, this term by z, and that one z in the least common denominator would cancel the z here, and if this were a z, it would also cancel this z. So we don't need to do that. If you already have a factor here, when you go to another term, you don't have to write that factor down. So, and I stress that if you have one z here, we wrote that down here, and you have only one z here. If you have more than one z, then that's another issue. But if you only had one z here, you would not write down another z here. You want less is best. You don't want to getting a linear equation at the end of the day into having to solve a quadratic equation, or worse yet, a cubic equation. So you really do want the least common denominator. So again, let's go over it. We first copied this z down, the first denominator, and this 2 we need to copy down because it's different than a z. This 2 is different than a single z, so that's why I'm copying this 2 down. And that gives us 2 times z. So what do we do with that least common denominator? We multiply both sides of the original problem by the LCD. So first I'm going to write, I first copied 2z here, and then this side in parentheses. So that would be 4 plus 6 over z right here. Equals, I first put the LCD here, 2z, and then copy this 5 divided by 2 right here. Since it's a single term, I don't have to put it in parentheses. So now, multiplication over addition, distribute. So this is 2z times 4. 2 times 4 is 8z. Plus 2 times 6, 12. This z is going to end up upstairs, so we're going to have a z up here, divided by this z. So we're really going to get let's do it this way. So this is 2 times 6, which is 12. So the z ends up here, and then we have a z down here. So that z divided by z is 1 times 12 is just 12. So we have 8z plus 12 on this side equals 5z on this side. Let's solve for z. The opposite of adding 8 is subtracting 8. So let's subtract 8 from both sides. So we get 12 from here. 5 minus 8 is -3, and then we have z. Now we want to divide both. So this -3 is participating in multiplication. The opposite of multiplication is division. So let's divide both sides by -3. -3 divided by -3. That's 1. Negative divided by a negative is a positive. 3 divided by 3 is 1. 1 times z is just z. It's important to understand why we do the operations we do. It helps us retain and get correct answers. So that's what we have on this side, and then we have positive over negative is a negative, and then we have 12 divided by 3, which is 4. So we want to go and check that -4 to make sure our no denominators are 0. If we plug -4 in for z, that entire denominator is -4, which is not 0. So this is our answer. -4 is our answer. -4 goes up here in the box. Any questions on this particular topic? So anybody have any questions on so far solving rational equations? Is it making sense? How about giving me, raising your hand? Does it make some sense to you? I don't expect it to be 100% crystal clear at this point, but is it making some sense? Okay, that's good. That's good. I just want to see. That's good. Feel free to always raise your hand, reach out to me, whatever you need to do. Come to virtual office hours. If you have time and you want to, you hopefully be in a virtual study group that's at a convenient time for you. We'll see how that goes, but I'm hoping it works out. So let's see how much time we have left. We've got a little bit of time. Let's take a look at another problem. Let's look at this one. Solve for V. So we have 7/2V equals 1/6 minus 8/3V. Now, when it says to completely factor, it means factor even numbers like 6. So this 6 is 2 times 3. 2 times 3 is 6. That's important. It'll save you a lot of work if you see that. And with more work comes more, there's more chance of error. So I factored that. Now, the next step, find the LCD. So we go to the first fraction, just copy over the denominator, 2V. Copied over 2V here. Go to the next denominator. Is there a factor of 2 in this 2 times V already? And the answer is yes. So we do not need to put another 2 there. That single 2 is going to get multiplied times this fraction upstairs, times this fraction upstairs, times this fraction upstairs. So that 2 will cancel this 2, that same 2 will cancel this 2. So we don't want to put it there. This factor of 3, however, we don't already, at this point, we don't have this 3 here. So we just have 2V here. So we definitely need to put a 3 up here in order to cancel this 3. So we have to include this 3. And we move along to the next denominator. Do we already have a 3 has a factor here? And the answer is yes. Do we already have a V has a factor here? The answer is yes. So this is the smallest common denominator that will work for this problem. Anytime you start adding in factors, that it's, in a sense, there's no harm in listing a 2 or a 3 again, but it overcomplicates the problem. And especially if you put in another V here, and you had V times V, you're introducing V squared. So you might not be down to a linear equation at the end of the day. You may be down to something else, making it more complicated, like a quadratic equation. So you really want to understand how to do that, what we just did. So let's see if it really does work, what I'm saying. So let's go through this again. The 2V, I just copied down. This 2, I asked myself, is there already a 2 here? Yes, so I don't need to put a factor of 2. Is there already a 3 here? At that moment in time, there was not a 3 here, so we needed to put a 3 here. Then we move along. Is there already a 3 here? Yes, we don't put it in. Is there already a V here? Yes, we don't put it in. Because that 3 and that V are going to be doing double duty and cancel what we need it to cancel. So let's multiply the 2 and the 3 together to get 6. and then multiply times that v. So we get 6v. What do we do with the least common denominator? We multiply both sides of the equation with it because we're trying to cancel or remove those denominators. I mean, there's really going to be an understood one in each one of those denominators, but that doesn't cause us problems when we are solving equations. We're still going to be able to solve a linear equation. So we multiply both sides of our equation by our least common denominator. So 6v times what's on this side, 7 over 2v, equals 6v times what's on this side, 1/6 minus 8 over 3v. So let's see what we can cancel here. Let me not get too far ahead of myself. 6 times 7 is 42. V, that V goes here. And then we have a 2v in the denominator. And the v's cancel. Equals. This is multiplication over adding a negative, so multiplication over addition. So we want to distribute, so we get 6v times 1/6 plus times a minus is a minus, and we would get 6v times 8 over 3v. So let's see what we can do. 42 divided by 2 is 21. V divided by V is 1. 21 times 1 is still 21. This is 6 divided by 6, which is 1, times what's left is what's left, and that is V times 1, which is V. Minus 6 divided by 3 is 2. V divided by V is 1. 1 times what's left is what's left. And then we have the 8 right there. Whoops, the 8 right here. So we get this. So this is 21 equals V minus 2 times 8, 16. Add 16 to both sides. That's the opposite of subtracting. Adding, add 16 to both sides. And we get 1 plus 6 is 7, 2 plus 1 is 3, equals V. Now that 37 equals V. 37 isn't going to make this denominator 0. Is not going to make this denominator 0. So we're good. Our answer is V equals 37. Let's take a look at one more and then call it a day. Does anybody have any questions? Anybody have any questions? Let me see here. This one is due. So the one we just finished is due on Thursday. This one is due on Sunday that we're working on now, but we have class on Thursday. And so it's really, I don't have to like squeeze it in. So I'm going to just do this one and make a note of it. And if I forget, please remind me if you remember. So that would be great. So here we're looking at this problem. Now, one little tip I will mention here is I would, since you've got a string of terms here, and by that I mean you've got two variables or no, you've got variables or numbers. Variables just stand for numbers. So you've got two terms here because it's u plus a -3. And two terms here, u plus a -3. I would put parentheses around these terms because later on in the next example, well, maybe it's not quite the next example, but down here, it will be very important to put parentheses around these terms. So I just want to start it early. I guess we're going to have two we have to finish on Thursday. That's okay. So let's go back to this particular question. So I want to put parentheses around u minus 3 and u minus 3. And so the LCD, I'm just going to take this first one that has parentheses around it and write it as u minus 3. I just think it's much clearer what to do. Maybe you could get away with not doing it in this problem, but other problems it's going to be quite confusing what to do unless you use the parentheses. So the LCD, we write down this this u minus 3, and then this u minus 3 with parentheses around it, we already have it there, so we don't write it down again. So we want to multiply both sides of this equation by u minus 3. So I'll write down u minus 3 here times what? All this entire side I just copied here, equals u minus 3 on this side times what? Times 2. What we do to one side of an equation, we must do to the other side. So now what do we do? This is multiplication here, understood multiplication sign here, adding a negative, which is, you can sneak in a plus sign, so we have adding. So we really have adding going on. So we can distribute. So we want to take this u minus 3, copy it over, times the first term, which is 5 over u minus 3. Now that u minus 3 would look kind of funny if you didn't have parentheses around it. And then minus this u minus 3 from the outside times 3 over u minus 3. And then over here on this side equals 2 times u minus 3. So that's what I think maybe you're getting some sense of the importance of putting parentheses around terms. So let's look at each term by itself. U minus 3 divided by u minus 3, that represents the same real number. So that's a number divided by itself is 1. So that's what we've got here. 1 times 5 is 5. Minus, these guys cancel. Minus 3 equals, let's distribute the 2 through, 2u, and then 2 times negative 3, which is negative 6. So we get this. So we get 2u minus 6. Solve for u. First thing, I want to move the 6 to the other side. It's subtraction, so the opposite is addition. Add 6 to both sides. So we get 2 plus 6, which is 8. And then this equals 2u minus 6 plus 6, which is 0. 2u plus 0 is 2u. So that's what we get here. And we need to move the 2 to the other side. It's participating in multiplication, so let's divide both sides by 2. Divide by 2, divide by 2. 8 divided by 2 is 4. And this side is 2 divided by 2 is 1 times u is u, so we get u equals 4. And if we go and plug 4 into the denominator, we get 4 minus 3, which is 1. 4 minus 3, which is 1. 1's fine to have in the denominator. It's just that we cannot have 0. So before I go back up there, I am going to show you here is a problem with no solutions. So they really do exist in ALEKS. So make sure you're checking if you're working ahead of where we're at in class. Make sure you're checking. And I don't know, I can't tell you 100% for sure that you aren't going to see that phenomena come up in any of the topics that we just did, because I simply cannot see every ALEKS question. So do you have any questions about anything that you would like to ask me today? I don't want to start another problem. We've got about 3 minutes left in our class. So do you have any questions or comments or anything that you want to say? And I have a question for you. I'm just curious. Are any of you interested in forming those study groups? I have created a form that I sent the link to this morning, where it has every day of the week where are you available Monday mornings, Tuesday mornings, Wednesday mornings, and so forth. Are you available Monday afternoon, Tuesday afternoon, and so forth. Are you available Monday evening, Tuesday evenings, and so forth. So are any of you interested in doing that? If you are, could you put your hands up? I'm just curious to see how much interest there is in doing that. We've got 2 anymore. Well, hopefully 3. Hopefully with my 2 classes at 4, I can make that work. So there's 1, 2, 3. Okay, I see a few more. Okay, so let's try to make that work. And you have until Friday to fill out that form. If you could do that by Friday evening, that would be great. So I think between my 2 classes, I can make it work, even though it may be with one with the other class, since we're all so busy. I will do my best to facilitate that. And thank you for attending class today. It is worth attendance points, but I'm glad to have you all here, and I hope you're getting something good out of class. Feel free to reach out to me if you have any questions. And let me make sure I'm taking attendance before you all leave. Speaking of attendance, so I am going to take attendance here by using screenshots. I feel like that works about the best for me. Thank you all. You're free to leave and have a nice day, and I'll see you on Thursday. Feel free to stick around if you have questions. Let me see if somebody has a question here. Does anybody have a question for me? Thank you for all your responses.
Hi.
Hi.
I was going to see if, did y'all record your first class? Because I missed the first class.
So let me see if we recorded the first class or not. Let me go into Canvas for you.
Okay. I mean, the first and the second would be great.
Let me make sure. Let me see if I'm still sharing my screen. I should be. Let me go down here. Yes, I'm still sharing my screen. And you're still there, right? So, okay, this is Canada?
Yes.
Okay, so let's go into Canvas here and take a look. I don't want to answer that question for sure because, you know, it took a bit of getting used to the technology last week, especially.
Right, I understand.
And so I didn't, even though my intentions were good, it didn't happen in all of them. So let's see what we got.
I'm still having issues too.
Yes, it's a lot. One of our department co-chairs sent out a list of everything we have to do differently, and it was quite a long list. So let me go in. So this is this. Gotta make sure I get into the correct course. Okay, so I want to go into student view, so it's more like what you would see.
Wow, does that mean?
I'm not sure who it is. Can somebody else everyone else turn off your mic except for Canada, please? Canada, why don't you turn off your mic and then listen to me, and then you can turn it back on and see if that's what's causing it.
Oh, I see.
Okay. Okay. So
sorry, I use my computer and my phone so I can like.
Oh yeah, that does cause problems. I've done that too. So you can use both 2 devices if you shut the mic off on one of them.
Right. I'm usually on top of it, but I wasn't that time.
Yes. It's such a learning experience. Sometimes I use my phone, but I have to turn it off to monitor chat. Chat. It just depends on what I'm doing.
Well, I like to look at like our lesson or the module or whatever and be able to see what you're doing or, you know, whoever's doing.
So I collect on modules over here.
You don't really do much in Canvas, right? This is all like in the Alex, right?
This is mostly in Alex, but we have to store some things in
Right.
Canvas because there's not a good place to put it in Alex nor a good place to put it in Teams for that matter. And this is true of videos. So we have nowhere where else to put them. The link.
So video library.
There. See, you've got them for both Tuesday and Thursday.
Yeah, I'm going to be working on those. And I do have a tutor just to make sure I keep up because since I switched classes, I just couldn't do that night class.
I see. And also, let me just go back to the homepage and show you this. I want to show you, I have posted my virtual office hours. So this is the page that you would enter on Canvas, the homepage. So if you scroll down, now I've put this link is the link to get into our team for our virtual class. So I'm not going to send out those emails anymore. I put those here and I put that link here now. Does that make sense?
Yeah.
And these are my virtual office hours, which are after class on Tuesdays and Thursdays, and Thursdays 7 to 8, and Sundays 7 to 8. And these are virtual office hours for all my 4 Alex classes because they're all pretty much
7 to 8 in the morning or in the evening.
It's 8 in the evening. Can you see on Canvas? No.
Oh yeah. Okay.
Yeah.
Like I just shut that window off on my computer. So
it's okay. It's okay. So you can go there and look and make sure you've got it correct.
Okay.
Yes. So our objectives are, I'm not going to say 100% of the time in the course, but most all the time are due on Thursdays and Sundays. So that's like a place to come to get help on on your where you're on the topics that you're having the most issues with. So did that answer your questions?
Oh yeah. Like probably tonight and some of tomorrow I'm gonna just watch the last classes. Try not to burn myself out too fast, but like you know, I'm trying to get my leg in and be on track and on time with you guys.
Yes, that's good.
Because I took algebra. I had college algebra last semester. I don't know how I tested into that class. I'm 33. Like I haven't done algebra in 100 years, and they the teacher's going really really fast. It's like we learned something, then that next class we learned something way different, and I was still like, wait.
I see.
Wasn't right.
I've had a lot of students be successful with Alex in this course that have been out of school for quite some time. It just
I've heard that too. I took math lab last semester.
Mm-hmm. Yes, and they have determination. They really want it so bad that they are motivated.
Yeah, like I withdrew the class because I wasn't I was behind, and I want to learn it so I know how to do it. I don't want to just get by on the skin of my teeth. Like I want to be able to know. You know what I mean?
Mm-hmm. Yeah. Understand it. It's easier to do well in a class if you understand it.
All right. If you're there.
Yeah. Yes. That's good.
Okay.
It's nice to meet you.
All right. Well, thank you very much, Miss
Anne.
Anne, yes. Bear.
Yeah. Bear.
All right.
That's I like to say take care, Ann Bear now because it rhymes.
Yeah. Yeah. That sounds good. And I will see you Thursday.
Yes.
And if I have any questions, I will contact you.
That sounds great, Canada. Nice to meet you. Nice to have you. Bye.
You too.
Take care.
All right, you too. Bye.
Bye. MG, do you have a question? Madeline, you have a question? Okay, well, I'm gonna hang up the meeting now. I'm going to leave the meeting right now. So I'm going to